Hi, everybody. It's Professor Mitchell. We have reached the last section of Chapter 9, which is graphing linear inequalities in two variables and systems of linear inequalities. In this section, we will graph a linear inequality in two variables and then solve a system of linear inequalities. The SLO for this section is to construct graphs of inequalities. All right, so when we're talking about a linear inequality in two variables, that is an inequality that can be written in one of the following forms. AX plus BY is either less than, greater than, less than or equal, or greater than or equal to a number C. So think about the standard form of a linear equation, and it's just got the equal sign replaced with an inequality symbol. Where A, B, and C are real numbers and A and B are not both zero. The solutions to these types of inequalities will be ordered pairs. An ordered pair is a solution of an inequality in X and Y if replacing the variables by coordinates of the ordered pair results in a true statement. In other words, you plug in the ordered pair and you get a true statement. So what I would like to do first is to determine whether each of the following ordered pairs are solutions of the linear inequality x minus 2y is less than or equal to 4. And then I'm going to use the results to show you what the graph of this inequality looks like. So I'm going to switch over to the tablet. I've got this all ready to go. All right, so what I'm going to do is substitute each of these ordered pairs into the inequality. For example, if I put in the ordered pair 0, 0, I get 0 minus 2 times 0 is less than or equal to 4. And when you simplify the left-hand side, you get 0. So this statement says 0 is less than or equal to 4. And that statement is true, right? 0 is less than or equal to 4. All right, and we'll just continue like that throughout the rest of these ordered pairs. The next one is 4, negative 2. Putting that into the inequality will give us 4 minus 2 times negative 2 is less than or equal to 4. 4 minus 2 times negative 2 is 4 plus 4, which is 8. And of course, 8 is less than or equal to 4 is a false statement. All right, so at this point, if you want to pause the video and try the rest of these, I encourage that. Come back and compare notes when you're ready. So I will continue with 1, negative 3. 1 minus 2 times negative 3 is less than or equal to 4. Is 1 plus 6, which is 7. And of course, 7 is less than or equal to 4 is also a false statement. 1 minus 2 times 2 is less than or equal to 4 gives me 1 minus 4, which is negative 3. Negative 3 is less than or equal to 4, so that's true. 2 minus 2 times 0 is 2. 2 is less than or equal to 4 is a true statement. And finally, 2, negative 1. 2 minus 2 times negative 1 is 2 plus 2, which is 4. All right, so I purposely included this one. 4 is less than or equal to 4 is a true statement. I like to think of it as sort of just barely true. Because if I replace that less than or equal to with a less than, it would be false. Okay, for all the rest of these, it doesn't make any difference. Okay, so now, sorry, I have to switch back to the presentation and then switch right back to the tablet. I want to look at these points on a graph along with the line x minus 2y equals 4. Now, what I have done is I have already graphed that line. You should be an expert at this point at graphing linear equations. Of course, we will review it when we get into the sort of real examples. Okay, but what I'm going to do is plot each of these ordered pairs. And what I'm going to do is I'm going to use green for the ones that made the inequality true. And I'll use red for the ones that made it false. So let me start with all of the true ones. The first one was 0, 0. So let's put a green dot there. The next true one was 1, 2, which is up here. Then we had 2, 0. I hope I'm not making you dizzy, switching back and forth. And the other one that made it true was 2, -1. I'm going to use yellow for that one as in caution. It just barely made it true. All right. 2, -1. Oh, look at that. It's right on the line. All right. Now let's go back and do the ones that made it false in red. 4, -2 is down here. Are you starting to see where this is going yet? Maybe after one more. 1, -3 is right here. And was there one more that made it false? Maybe that was it. Nope, that was it. All right, so the point I'm trying to make here, no pun intended, is that all of the green points, notice, are on one side of the line. All of the red points are on the opposite side of the line. The yellow point is right on the line. So it turns out, and I'm going to tell you this officially in just a second, every point on the, let's say, top side of this line is going to make this inequality true. All right, if you don't believe me, pick your favorite point on the top side of the line, plug it into the inequality. Remember, it said x minus 2y is less than or equal to 4. It will make that inequality true. All right, so when we graph these inequalities into variables, the graph is what we call a half plane. It's a line, and then one side of the line is shaded. Now, the other thing I'll mention is that if this inequality had said x minus 2y is less than 4, then the points on the line would not be included. And so the way that we're going to indicate that is by making the line a dashed line. Sort of like this. Okay. All right, so let's go back to the presentation and make this all official, and then we'll get into the actual examples. We're not going to do any more problems exactly like that. What we will do instead is what's described here. So the first step is to graph the boundary line, which is obtained by replacing the inequality symbol with an equal sign. Now that line will either be a solid line or a dashed line, depending on what the inequality symbol looks like. You're going to make the line solid if the inequality symbol includes equals. In other words, if it's less than or equal or greater than or equal. Okay, because in that case, all of the points on the line are part of the solution set. However, if the inequality symbol is less than or greater than, then you will make the line as a dashed line. Once you have graphed your boundary line, you're going to choose one point. You only need one point because remember, all the points on one side are solutions. All the points on the other side are not solutions. So just pick any point. The only requirement is that it cannot be on the line. So you'll have lots and lots of choices. Substitute it into the original inequality. And then one of two things will happen. Either that point will make the inequality true, in which case you will shade the half plane that contains that point. And I remember many years ago, I taught a class where a student came up with this way of remembering that: go toward what's true, right? We like what's true. You want to go towards the truth, okay? So shade towards the point that made the inequality true. However, if your test point makes the inequality false, which it will sometimes, then you're going to shade the half plane that does not contain that point. So stay away from what's false. Go towards what's true, stay away from what's false. All right, so let's try that. The first example, we're going to graph the inequality x plus 3y is less than or equal to 3. So let's go back to the tablet. All right, here we go. So the first step, and if I had it to do over again, I would have kept a blank page for this, but that's okay. I think we'll manage. The first step is to graph the boundary line, which is x plus 3y equals 3. Now remember, way back in chapter 3, we talked about 3 different methods for graphing linear equations. I tend to prefer 2 of them, either the intercepts method or the slope and y-intercept method. When the line is written in this form, this is standard form, I tend to usually think that the intercepts method is the easiest, okay? A lot of students like to use only the slope and y-intercept method, and they use that all the time, and that's fine. All right, so the x-intercept, remember that's what you get when you put in y equals 0, is going to be x plus 3 times 0 equals 3. In other words, x equals 3. So that means the point 3 comma 0 right here. And then the y-intercept, that's the point where x is 0. That's going to look like 0 plus 3y equals 3, which means 3y equals 3. In other words, y equals 1. So we're talking about the point 0 comma 1. All right, so now I will connect those 2 points with a line. Remember, the inequality was less than or equal, so that means this is going to be a solid line. And it's going to look something like this. All right, so now we just have to decide which side of that line to shade. So for that, I'm going to pick my test point. So if you had to pick any point that is not on this line, what point would you pick? I would pick 0, 0. You don't have to pick 0, 0. It just happens to be a very easy point. You can't always use it because sometimes it will be on the line. Okay, so test point 0, 0. Remember, this goes into the original inequality. So that's going to give me 0 plus 3 times 0 is less than or equal to 3. Oh, and by the way, 0, 0 is right here. In other words, 0 is less than or equal to 3. So is that true or false? That is true, right? So we like what's true. We want to go towards what's true. So that means I'm going to shade the underside of this line. All right, and that's how it works. So now let's look at the next example. The next example is, oh, it says Mylab practice. We're going to graph the inequality in homework problem number 6 because I want you to see how this works on Mylab. All right, so I just pulled up homework problem number 6, and my version of it is asking for the graph of 2x plus y is less than 4. And maybe just for variety this time, I will graph the line using the slope and y-intercept method. All right, so that's the first step. Graph the line 2x plus y equals 4. So in order to use the slope and y-intercept method, I have to solve the equation for y. So that gives me y equals negative 2x plus 4. All right, which has a y-intercept at 0, 4, and has a slope of negative 2, which I'm going to think of as negative 2 over 1. So I'm going to rise negative 2, which means go down 2, and then I'm going to run 1. So it's going to pass through that point, and it's going to pass through this point. Okay. And then before I draw this line, notice that the inequality symbol is less than, as opposed to less than or equal to. So this time the line is going to be a dashed line. Something like this. All right. So now we're going to choose our test point. And once again, I will use 0, 0. When I put 0, 0 into the original inequality, I get 2 times 0 plus 0 is less than 4. In other words, 0 is less than 4, which is true again. So here's 0, 0. We're going to shade towards 0, 0. I guess I'd call this the left side of this line. Okay. Now remember, I promised to show you how to put this into Mylab. So let's look at that now. All right, so I had a little glitch, and this problem that you're looking at here is just slightly different from the one you just saw me doing on the tablet, but it's close enough, so I'm just going to go ahead and do this one. So when you do these on Mylab, the first thing that you have to do is graph the line. So let's enlarge the graph. Remember to draw a line in Mylab, you use the line tool, which is right here. So I'm going to click on that. This line is 3x plus y equals 4, which has the same y-intercept as the one that we were just doing. The only difference is the slope is slightly different. So if I was doing 2x plus y equals 4, I would go down 2 and over 1. On this one, I'm going to go down 3 and over 1. So that is the only difference between this one and the one you just saw me do. All right, so once you have your line graphed, the next thing that you need to do is either leave it solid or make it dashed. Remember, this needs to be a dashed line because it says less than as opposed to less than or equal to. So you just go over here and click on Make Selected Object Dashed. All right, and then finally, we need to shade the correct side of the line. So we do that with the paint can right here. So I'm going to click on the paint can and shade the left side of the line like that. And we are all done. So I will save my answer, check my answer. Woohoo! That is correct. All right. So now we're going to talk about systems of inequalities. The solution set of a system of inequalities is the set of points that make all of the inequalities true. So a system of inequalities consists of two or more inequalities. And so if we want our points to make all of the inequalities true, then we're going to find the region for each individual inequality. So that'll be a half plane. And then the set of points that makes all of the inequalities true is going to be the region where all of those half planes overlap. All right, so in these examples, it'll just be two inequalities. So we'll just be looking for two overlapping half planes. All right, so the first example, we're going to graph the system of inequalities. Negative 2x is less than y, and x plus 2y is less than 3. So let's go over to the tablet. All right, and this time I'm going to do my work on another page, so I have more room. So the first thing I have to do is graph the line y equals negative 2x. Notice this is in the form y equals mx plus b. The y-intercept is 0. And the slope is 2. I'm sorry, negative 2, as in negative 2 over 1. All right, so, and I think I'm going to do this one in blue. All right, so here is 0, 0. Now I'm going to go down 2 over 1. And why not one more time? Down 2 over 1 again. All right, and finally notice that this is a a less than, as opposed to a less than or equal. So this needs to be a dashed line. All right, it's going to look something like that. All right, now let's talk about the region for this line. Unfortunately, I can't use my favorite 0.00 for this one. So I'll use, how about 1, 0? Okay, 1, 0 is not on the line. So we're going to test 1, 0. Now let me make sure I have the correct inequality for this. Negative 2x is less than y. If I put in 1 for x and 0 for y, I'm going to get negative 2 times 1 is less than 0, which says negative 2 is less than 0, and that is true. So we want to shade the side of the line that includes the 0.10, which is the right side. All right, and now I'll do the same thing for the other inequality. X plus 2y is less than 3. So starting with x plus 2y equals 3, I'm trying to decide how to, well, you could use the intercept. You could really use any method. I'm just noticing that with this particular line, one of the intercepts is going to be a fraction. You know what? So let's deal with that, because that's going to happen sometimes. So I'll use the intercepts method for this one. Let's see. So the x-intercept, that's where y equals 0. Gives me x plus 2 times 0 equals 3, which means x equals 3. This line I'm going to do in yellow. No, I'll wait until I have some more stuff to put over there. Okay, y-intercept. That's the point where x is 0. So that's going to give me 0 plus 2y equals 3. 2y equals 3 means y equals 3 halves, also known as 1 1/2. All right, so now let's go ahead and graph the line. I'm going to do this one in yellow. All right, so here is 3, 0, and then 0, 1 1/2 is right about here. This is also going to be a dashed line because the inequality symbol is less than, as opposed to less than or equal to. Okay, so this line is going to look something like this. All right, and now for my test point, this time I will use 0, 0 because it's not on this line. When I put 0, 0 into the original inequality, which was x plus 2y is less than 3, I get 0 plus 2 times 0 is less than 3, which says 0 is less than 3, and that is true. All right, so shade the side of the line that includes 0, 0, which is going to be this part here. Okay, so now we have to talk about the actual solution set for this system of inequalities. It's where these two half planes overlap. Now, there's a reason I'm using blue and yellow. It doesn't really work out when you're using, a digital pen like this. Would be better if I was using paint. When you mix blue and yellow, you get green. All right, so I was kind of thinking that if you did this with blue and yellow paint or even blue and yellow highlighter, I often recommend to my students that you use highlighters to do this. Then the overlapping region might look kind of green. Anyway, hopefully you can see the region where these two things overlap. It is the region down here. I'm just going to shade it a little darker. When you do these on the computer, which I will show you next, you actually don't do any shading until the very end. You do it on your paper and then just use the paint can to show the computer which region you want to shade. Okay. So it would be this region here. If I was doing this on paper, that's nice and clear which one I mean. All right. So now we'll go to the last example. And this will be a Mylab example. All right, so here's the example. I was originally going to show you a different one, and then I thought that one seemed a little too similar to the one I just showed you. So I wanted to do something a little different. All right, in this problem, we will be graphing 5x plus 2y is less than -10, and x is greater than or equal to -5. All right, so again, let me go on to the next page and I will work on 5x plus 2y. 5x plus 2y equals -10. Got to graph that line first. I will do this one using the intercepts. So the x-intercept is where y is 0. Gives me 5x plus 2 times 0 equals -10, which means 5x equals -10, which means x is -2. And then the y-intercept, where x is 0, 5 times 0 plus 2y equals -10. Means 2y is -10, which means y is -5. All right, so let's see, x equals -2. So that's here. Y equals -5. And this one is another less than, as opposed to less than or equal. So this is going to be a dashed line. All right, and then I'll use 0, 0 for my test point. The original inequality is 5x plus 2y is less than -10. So when I put 0 in for x and 0 in for y, I get 0 is less than -10, which is false. Finally, I've been waiting for one of these to come out false. So remember, if your test point makes the inequality false, that means you want to shade away from that point. Okay. 0, 0 is on the right side of the line, so we're going to shade the left side. All right, so now let's look at x is greater than or equal to -5. Starting with the line x equals -5. Now, hopefully you remember, x equals -5 is a special kind of line. It is a vertical line, right? And it passes through, well, any point whose x coordinate is -5, for example, -5, 0, or -5, 2, or -5, -4. All right, so that's really all I need to know to graph that line. Okay, so here is -5, 0. This line is going to be solid because the inequality symbol is greater than or equal to, as opposed to just greater than. All right, so now how do you handle the test point with a vertical or a horizontal line? Well, technically the same way. This time for my test point, I am not going to use 0, 0. I am going to use 0, 1, just to kind of illustrate something. Okay, so the inequality is x is greater than or equal to -5, right? Okay. Greater than or equal to -5. So the way that you substitute the ordered pair 0, 1 into this inequality is you just basically don't do anything with the y coordinate. So when you put 0, 1 in there, this is just going to say 0 is greater than or equal to -5, and that is true. So with respect to this line, we will shade towards the point 0, 1, which is over here. So this will be on the right side of the vertical line. Okay, and now I think it's pretty clear what this region is. Okay, my this was bothering me a little bit. This went a little wonky here. At some point up here somewhere, I guess, these two lines are going to meet, and that'll be sort of the top corner of the region. Okay, so we're talking about this region. Oh dear, right here. Okay. All right, so now let's look at that on Mylab. And this time I want to make sure that I share the correct screen, because that's what happened to me last time. Okay, so I'm sure I'm on the right screen. So what I'm going to do is first graph the 5x plus 2y equals -10 line. That was the one that went through x equals -2 and y equals -5. And it is a dashed line, so we want to make that dashed. Now, the difference when you're doing a system of inequalities is you're going to graph your two lines first and then do the shading at the end. So remember, we don't shade two regions on the computer and then see where they overlap. We just indicate the overlapping region. So that's why it's important to do it on paper first. All right, so line tool again, and now I'm going to draw the vertical line over here. So now second point can just be anything directly above or below. This line I will leave as solid. And now finally, I will turn on my paint can and I will color this region right in here. And that is correct. Woohoo! All right, so I just wanted to double check, but yes, that is going to do it for section 9.4, and that's going to do it for chapter 9. We'll see you next time.